Okay, here we are once again in front of a blank Excel screen with our formulations. This time we have the formulation here, the network model. We have also included the linear programming model on the right. And the reason is because for this first rendition of how to solve it with Solver, we're going to be do the same thing to this LP model that we have done to the other LP models. When we solve it next time, we are going to make less use of the LP model. And when we finally solve it with AMPO, we're just going to go straight from the network into the to the solution. But let's here do what we've normally done, which is to solve our LP model with our standard form. This is just, I made it up, so there's nothing magical about this format, just means I don't have to think a lot when I set it up. So we're going to follow the same variables as in the LP model. Okay, and then we're going to have an objective / left-hand side, and we're going to have a right-hand side, and we can start to put in the data. Okay, and then we can put some product. And then we move on to the constraints, F1, F2, EC, W1, W2. And then we have an upper bound on some variables. We have an upper bound on F1, F2. And we have an upper bound on DC, W2 right down here. And those are the names of our constraints. And now we start filling these in. The coefficients will be 1, 1, 1 for this one. And then we move the 50 over to the right-hand side. And then for this one here, we have 0, 0, minus 1, 1. And then we have 40. For DC, we have minus 1. We have 0, minus 1. 0 minus 1 plus 1 equals 0, and W1 is minus 1, 4 zeros, 1 minus 1, and the right hand side is minus 30. And for W2, we have all zeros until we get to DCW2, and we have a minus 1, a minus 1, and a 1, and a right-hand side of minus 60. Okay, for the upper bounds, we have F1, F2, so we'll have a 1 there, and for DCW2, we'll have a 1 there, and for the upper bounds, they are 10 and 80. Okay, so we're ready to solve. We go to data, we go to solver, we reset all from maybe some of previous efforts, and we go to the objective function, which is there, and we go to minimize, and we got to specify all the cells and changing cells what we are changing, which is all of these, and then we need to add a constraint. One constraint, oh, we didn't, let's cancel out of here. Let's close out of here, and we need to carry this down below. Oh, okay, we did not put a $ in front of these. which we needed to do. So let's do that. So when things go wrong, you gotta figure out what the heck did I do wrong. So that's one thing we had done wrong. So now we go back to our data and we go back to our solver. And we have already the objective, we have already the min, we have already the changing variables, and now we go and add constraints. And now we can say that here we will have these 5 values have to be equal to these 5 values. And then we add another constraint where these 2 values have to be less than or equal to these 2 values. And we say OK. And now we solve. And we say OK. And we get a solution. So let's pause a moment and let's draw that solution onto our diagram. So F1W1 is going to be 30. And F1DC is going to be 20. And F1, F2, 0. F2DC is 40. DCW2 is 60. And that satisfies the 60 demand, and that satisfies the 30 demand. So that's the solution. But let's look at that critically. We notice that the F1W1 transfer costs $900 per unit, which is very high. And you'd want to use it the least possible. Why are we not using this link to its maximum capacity? So this solution seems to be incorrect, and we have to trace why that it is incorrect. So we need to take a pause. Okay, so after looking for the culprit for a while, we discovered it. I discovered it. And I realized that when I drag these cells, and you may have observed this while you were watching me do this, but I didn't quite go far enough. So I have to go to H, and I have to go to H. And I'm glad these things happen. And then I have to drag it down and apply it to the others as well. And then I have to resolve. So I want to solve quickly. There's nothing else to be done. And now we see a different solution. We see that DCW2, so let's just take a break so that I can put these new numbers on the graph. Okay, so we can get rid of these marks here and update them with the new values. So this is going to be 10, which is a lot better. And F1DC is going to be 40, which is the same as was before. And F2DC is going to be, sorry, that's F2DC. DCW2 is going to be 80, which is good. Now we're at the max. And I must have missed one. F1DC is, F1DC is, F1W1 is 10. F1DC is 40. Sorry. F1DC is 40, and then we get 80. So what's happening is we're minimizing the flow on F1W1, and we're taking DCW2 to the maximum capacity, and we get a lower objective of 49,000. Okay, so this is an important mistake that I made, if I can say that, in terms of teaching, is that you have to really critically look at your solutions. You can't just say, okay, it's solved, it found numbers, and now I'm going to run with it. And this is true for models small and large, and especially large ones, where it's hard to debug. So what you typically do is you start with much smaller problems, you make sure that they work, make double sure that they work, you vary the data all over the map. This activity is probably, we will not have enough time in this course to do that, but if you're going to do something at work or apply this, that is something that is extremely important to make sure that you don't run with a solution until you understand it. And there's somebody in OR who's famous who said people would rather live with a solution without a solution, that one that they can't understand. So if you give a recommendation and it doesn't make sense, people will stay away from it. They suspect that something is wrong. So if you have to convince people that it isn't just a computer that's telling you that, but you have to convince people that the model is correct and behaves properly. And that's a very important aspect of OR. As I said, probably one that we cannot spend enough time on, but certainly it's worth spending a minute or two to drill this message in. And that's the end of this.